Now the next thing that we want to do is add a transfer function. We want to add the ability to actually, pay with tokens or send tokens or, move them from one place to another. We'll take a look at that here in the documentation. We'll read about the transfer function here. It says this transfers value, amount of tokens to address 2, and must fire the transfer event. So this function should throw if the from account balance does not have enough tokens to spend. Note transfers of 0 must be treated as normal transfers and fire the transfer event. So let's see what we need out of this function. It is going to accept 2 arguments. It's going to accept an address that we're transferring to, and it's going to accept a value. This is going to be the amount of tokens that we want to transfer to. And it's got to do a couple different things. It's got to throw an exception if the person sending the tokens doesn't have enough. It's got to trigger a transfer event, and it's also got to return this specific value. It's got to return a Boolean value, which is going to be true or false, depending on whether the transfer was successful or not. Now we've got our work cut out for us. I'm going to sketch out what we need here. We need a transfer function. It's got to trigger a transfer event. It's got to trigger an exception if the account doesn't have enough. It's got to return a Boolean. And we'll just start with that for now. So we'll go ahead and sketch out our transfer function here. We'll start by declaring this function like this, function. We'll call it transfer, just like the standard. And remember we saw that it requires 2 arguments. It requires the address that we're transferring to. We'll use an underscore here for 2. And this is, again, the data type that we're transferring to. This address is a special data type in Solidity that corresponds to the users connected to the blockchain. And we'll do an unsigned integer value. And this is going to be the number of tokens that we actually want to transfer. Now, the visibility of this function must be public because we want it to, respond to the public interface. We want, people to be able to call this function when we are using this standard, and we're going to specify the return value. This will be Boolean data type, and we'll just call this success. All right. Okay, so that's how we declare this function. Now we'll have to implement a few things here. Let's go ahead and put these inside of our function. All right. Now we can also do this in a test-driven fashion. I'm going to go over here to our test file. And we'll start a new thing here. I'm going to add some lines so that we can have more room here. Let's start by saying it transfers ownership. We'll pass this a function. Now we'll do the same thing we've done every other test. We'll return Dapp token deployed. Then function. Get our instance. Oops. And we'll set the token instance. All right, so the first thing that we want to do is test the require statement, right? So we want to throw an exception if the account that we're trying to transfer from, the person who calls this function, the sender, like msg.sender, the sender of this function doesn't have enough tokens in their balance. So essentially we want to check this mapping that allocates the balance, and if someone tries to send tokens that they don't have, we want to stop the execution of this function and raise some kind of exception. And I'll show you how we do that. I'm going to actually just paste this in here. Okay, so we want to test this require statement by first transferring something larger than the sender's balance. So we know we only have, 1,000,000 tokens available. So we know that the sender won't have won't have this many tokens. That's, ridiculous. So we'll return the result of this, call then, and then we'll say assert fail. This is how we do this. And we'll catch, we'll say function, we'll get the error. And we want to assert that this error has a message. We want to say assert error message. We want to read something out of this, and we want to try to say that it contains revert. All right. And again, we're just getting, this is going to be the transaction receipt. Well, it's not the receipt since it's an error message, right? We're going to get the error. We're going to get the message out of it, and we're going to just ensure that it contains this substring revert. So we can do that, and we can try to run this spec, or this test, see what happens. Again, we haven't written any code for this yet. All right, so the message must contain revert, and that's not happening, just like we expect, because we actually haven't written any code yet. So let's try to implement that. Now let's recap. We want to say if the sender of this function, right? So msg.sender, sender, that we saw earlier. This is the way that we capture who's calling this function, like this. If this person doesn't have enough tokens to transfer, then we want to raise an exception. For example, if this person only has 1 token in their account and they want to transfer 10 tokens to somebody else, they can't do that because they only have 1 token. Similarly, if they only had 10 tokens and they wanted to transfer 100 tokens, they can't do that either. So we first want to read the balance of this person's account, just like we did here. Balance of msg.sender. And we're not going to assign this to anything like we did here. We're just going to read the value out of it. And we want to see if it's greater than or equal to this value. All right. This is the value that's getting passed in. So when we call this function and we say, I want to transfer 10 tokens to some address, we pass in the address that we want to send it to, and we pass 10 as the value. And we want to ensure that this person has at least 10 tokens in their account, which we're going to read with this balance of mapping that we created here, and that we use when we set the initial supply when we deployed the contract. So we'll do that like this. We'll do require. All right, and this is something that's special in Solidity. So require is just going to say, if this evaluates to true, continue function execution. And so everything else below will get run. If this is false, then stop function execution and throw an error. And if you're using gas in this transaction, which we are because this is writing to the blockchain, then all the gas spent up to this point will get used, but any gas remaining that would have gotten used here is going to get refunded to the sender. So let's try to run that. Triple test, see if our test pass. All right, our test pass. Now the next thing that we want to do is actually, transfer the balance. We want to take, the amount of tokens that we called, that we sent in this function, and transfer them from the sending account, right, msg.sender, and we want to assign those to the address that's getting passed in here. So the tokens are going to go from, this account to this account. And we can, do this in a test-driven fashion. So we'll go back to our test here. And we can say, well, let's just do this here. Let's do this. We'll say we'll return token instance. We'll actually do a transfer. We'll actually call it this time. We'll do accounts. We'll do it to account 1. And we'll say 2,500 or 250,000. Let's do that. All right. So let's do this from Web3 to ETH. Or no, sorry. We have accounts here. We'll do it from the first account. This is where the initial supply has been allocated. And we've returned this, so we'll call the promise chain, then function, and we'll say this is actually going to be a receipt that we'll inspect here momentarily. So we'll skip that step for now. Just notice that whenever we create this transaction, a transaction receipt's going to be here. So we'll skip the receipt for now, and we'll return the token instance, balance of the account that we sent these tokens to. Accounts 1, sorry. And we'll also tap into our promise chain, then function. We'll call this balance. And we want to assert that the, let's assert equal the balance to number is equal to, let's see here, 25 or 250,000. That's what we transferred here. And we're going to say it adds the amount to the receiving account. Okay. And we can also say we could check the balance of the, sorry, typo's getting a little crazy here. The account that sent the transaction, accounts 0. Okay. So we want to inspect this balance as well and say that that this balance actually went down by the amount that we transferred from. And we'll assert equal the balance to number, just like we did up there. And the balance of this account that sent the transaction has gone down by 250,000, right? So we started with 1 million, and we subtract 250,000 to get 750,000. And we'll say this deducts amount from the sending account. All right. Now we can run this spec and see if it passes. It should fail, as we expect. See if we got any errors in our test. No, just errors in the, just assertions that aren't passing, which is what we expect. Now, before we go try to implement this, I wanted to make a quick note about how we're calling some of these functions. You'll notice that I used call here, and I didn't use call here, and I'll explain why. So call in this case just allows us to call our functions and inspect. It doesn't actually create any transactions, right? So if I call this function, without using .call, actually call it directly here, it's going to create a transaction. And that's why we get a transaction receipt here instead of, the Boolean return value that we're going to implement at the end of our function here. So just in summary, this does not trigger a transaction, and this does trigger a transaction. And that's why we get a transaction receipt here that we will inspect momentarily. So let's go ahead and write the code that's going to make this spec pass. We'll say balance of. This is msg.sender. Again, this is the account that's sending the transaction. And we're going to deduct this with the decrement operator. We're going to make it go down by the value that was passed into the function, right? And we're going to increment the balance of the address that we're, sending these tokens to. And we're going to pass in 2. And we're going to increment it by the value. Now this is a very standard, just financial transaction that you might have seen in other programs. It's just deducting the balance from one account and adding it to another. And this is the code that we need in order to make this test pass. So let's give it a try. Oh, we got a failure. Let's see what it is here. Adds the amount expected, 250,000 to equal 250. Oh, yeah, sorry, I added one extra 0 in that test. We'll just change that here. Run our specs again. All right, and they pass. Okay, so the next thing that we want to do is trigger a transfer event. If we notice, back in our documentation, this says that all of the functions in the, that implement this ERC-20 standard, must fire a transfer event. And, this event has to transfer even for, 0 values. They must, trigger a transfer event anyway. So that's the next thing that we'll implement. We'll do a transfer event. In order to emit a transfer event, we must declare one. We can do that like this. It's pretty easy. We can say event transfer. And we will pass this some arguments. We'll do the address. This will be indexed. This is going to be the account that, that sent the transaction. Sorry, it's a syntax error. We're going to add the account that is going to. Sorry, I'm full of typos today, guys. And we're going to add the amount. All right. And we can actually go back to our documentation to see that event. I'll show you. Events, transfer. So we want an event that looks like this. Address is indexed as from, address is indexed to, and this is the value. So this event in Solidity is really just something that the contract is going to admit that a consumer can subscribe to. We can listen to this token at any time a event is triggered. We can get alerted about it. We can also listen to events that we care about. We can listen to events that are triggered from this account or to this account or for this value. Well, not for this value because it's not indexed, but yeah, you get the idea. So we want to trigger this event here, but we want to write the test first. We can test for events by looking at the transaction receipt, and that's what we'll dig into here. And I'm going to paste in these specs here. All right, let's see what they do. First, we're going to say that this receipt has logs. This is where our event information is going to be. It's going to be in the logs. And whenever we dig into these logs, we want to find the first one. We want to ensure that's an event. It's going to be a transfer event. And we want to make sure that this event has all the arguments that we expected. So it's going to be from this account because we just called it here. It's going to be going to this account because we just added that here. And it's going to be for this value, which is the same value that we pass into this function. So let's run this test. We expect it to fail. All right. It expected one event but got 0. So let's actually implement this event. It's pretty easy. Take that out. And we'll say transfer. This is how we call this event in Solidity. We'll say msg.sender because that's the account that it's coming from. This is the account that's calling this function. And we want to add the account that it's going to. It's going to be 2. And we want to give it the value. And that's just the value that's coming into this function. All right, so let's run this test and see if that passes. All right, it passes. Now the last thing that we want to do for this function is to return a Boolean value because that's also part of our specification. We can see that here. The value must return a Boolean. So we can do that in our function. We've also declared that here, returns a Boolean of success. But let's write the spec first. So we go into our test file, and we can, we'll just, let's basically, we'll do kind of what I said earlier. We'll call transfer with this call function. We won't actually trigger a transaction because we want to actually inspect the return value of the function, not just the transaction receipt. So we can do that here. Let's just do it below. Let's do it below here. We can do return. This will just be a fake transfer. We're not actually trying to do anything. We just want to inspect the return value of the function. So the token instance, the transfer call, and we'll say accounts. We'll go to account 1, and we'll say 2,500 or 25,000. This is the same kind of transaction we do here, and let's just do the same parameters. Okay, and we can close this out and say then. And this will be the actual return value of the function because we're using call. This is the Boolean value of success, which we defined. I'm sorry, let's kill that. And let's assert equal that the success is equal to true. Sorry guys, full of typos today. So let's run this test, see if it passes. We expect it to fail. All right, it fails. It expected false to equal true. It got false, but we wanted true. So we'll go into our function, and we'll basically just say return true. Now, we can specify this only if all of this code is executed successfully. That's kind of why this is here, to say that this function, worked. So let's go to our test and run it again. All right, and it passes. All right, so we have successfully implemented a transfer function for our token. Let's go ahead and commit some of these changes. So we'll git add dot. We'll add everything. We'll commit. We'll call this number 2, and we'll say transfer tokens. And again, I'm going to add a link to this commit at the end of this video. I'll put it down in the description below. This will be, up on GitHub, so you can check out this point of the tutorial. All right, and that's it, guys. That's it for today. That's part 3 of our series where we're showing you how to create your own cryptocurrency and your own ICO on Ethereum. We've worked on this ERC-20 token in a test-driven fashion, and that's our stopping point. So be sure to check out the next video when it comes out. Be sure to subscribe to the channel and turn on notifications with the bell below so that you can see that video when it comes out. And if it's already out, you can just check the link at the end of the video or just wait for the next video in the playlist. And until then, thanks for watching Dapp University.